If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip.
The question we're working on today is, evaluate the integral of x squared minus x plus 6 all over x to the third plus 3x dx.
Smash that like button and let's get started.
So we want to take our fraction x squared minus x plus 6 over x to the third plus 3x and write it as a sum of other fractions that we know how to integrate. So the way we do that is we factor the denominator. And our denominator is x times x squared plus 3. And that's its complete factored form. And so we could write our fraction as a over x plus bx plus c over x squared plus 3. Let's get a common denominator. So that's a times x squared plus 3 plus bx plus c times x all over x times x squared plus 3. And now we have two fractions with the same denominator that are equal, so their numerators must be the same. So we have x squared minus x plus 6 is equal to, and we're going to group them together by coefficients. So a plus b times x squared plus c times x plus 3a. And now what we'll do here is set up a system of equations where the coefficients of the left have to equal the coefficients on the right. So a plus b equals 1, c equals minus 1, and 3a equals 6. Clearly we could solve for a, and using that we could solve for b. So to evaluate the integral of x squared minus x plus 6 over x to the third plus 3x, what we're going to do is evaluate the integral of 2 over x plus the integral of negative x minus 1. We got those values from solving from a, b, and c. And we'll see that, negative x minus 1 over x squared plus 3. And we'll see that it's best if we break up that second integral. So we'll have 3 different integrals we need to evaluate in order to get the integral we wanted to evaluate. So we'll start with the integral of 2 over x. Well, the integral of 1 over x is the natural log of the absolute value of x, so the integral of 2 over x is 2 times the natural log of the absolute value of x. That one was pretty easy. Now we'll go on to the next one. Here we're going to see we could solve this using U substitution. We'll have u equal x squared plus 3, so du is equal to 2x dx. In our integral, we could rewrite as negative 1/2 the integral of du over u. Again, this is going to be negative 1/2 the natural log of the absolute value of u. And we're going to switch back. We started with x, so we should end with x. This is negative 1/2 the natural log of the absolute value of x squared plus 3. On to the final part, the integral of negative 1 over x squared plus 3. Here we have to use trig substitution. So we'll take x to be the square root of 3 times tan theta, and dx is the square root of 3 secant squared theta d theta. When we make this substitution, our integral is negative square root of 3 secant squared theta over 3 tangent squared theta plus 3 d theta. In our denominator, 3 tangent squared theta plus 3 is equal to 3 secant squared theta. So now we'll see that we have a secant squared theta in both the numerator and the denominator, so we could cancel those out. And we're taking the integral of a constant, which is just going to be that constant times theta. Now, in order to write theta in terms of x, let's take our initial substitution. And we could rewrite that to say tan theta is equal to x over root 3. Taking the inverse tangent of both sides, we see that theta is equal to tan inverse of x over root 3. So now we've evaluated all three of the integrals, and we could put it all together. So the integral of x squared minus x plus 6 over x to the third plus 3x is equal to 2 times the natural log of the absolute value of x minus 1/2 the natural log of x squared plus 3 minus square root of 3 over 3 times the inverse tangent of x over root 3 plus c.
Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.